Okay, hello my dears. If you're watching this video, we're going to talk today about the 2.3 writing equations of parallel perpendicular lines, and it's our second day of notes. So hopefully you'll be watching this on Monday and Tuesday, the 20th and 21st of September, because obviously, like I told you guys before, Ms. DeMassa will be doing some proctoring, so you'll watch this instead, and then we will talk about it on Wednesday and do an activity with it. So we've been talking about parallel and perpendicular lines. We know parallel lines will never intersect, and they also have the exact same slope. And we know that perpendicular lines have opposite sign reciprocal slopes, and they intersect at a 90-degree angle. Today, we're going to practice writing equations of different lines that go through a particular point that would be graphed on the coordinate plane. So we've got 5 steps that we're going to do for every single problem, and we're going to do these in order every single time. First step is we're going to rewrite the equation in slope-intercept form. Remember, that is y equals mx plus b, and the m is my slope, the b is my y-intercept. We only do that if it's needed. If it's already given to us in that form, then we're golden. Step 2, we're going to identify the slope, and we're going to substitute either a parallel or perpendicular slope into the equation. So depending on what the question asks me for, we're going to plug in the indicated slope. Step 3, we're going to substitute the ordered pair in to x and y into the equation. And then step 4, we'll solve for our b. We're going to solve for the y-intercept. We have to come up with a new y-intercept to write an equation. And then my final step is I'll take all the information that I know, plug it back into the equation to write one final equation. So let's take a look at number 1. Write an equation of a line parallel to y equals negative 2/3 x plus 1 that passes through the point negative 6, negative 1. So the negative 6 and the negative 1 are my x and my y values, right? It's like a point that I can graph on a line. I do not need to do step 1 because it's already written in slope-intercept form for me. So the slope of this equation is negative 2/3. It's given to me right here. Because it is parallel, and I'm writing the equation of a parallel line, I'm going to use the exact same slope. So for my m value, I'm going to use negative 2/3. Oh my gosh, hold on 1 second. I don't. I'm sorry. I have what's it called? I'm in the middle of a, I'm in the middle of a video. But what's that? I'm in the middle of a, yeah, is that what you want? Okay.
Thank you.
Yep. All right, dear. Sorry, I forgot my coffee cup in another class. Okay, so we are going to now substitute in the x value, the y value, and my slope into the equation y equals mx plus b. So we're going to substitute in the pieces that we know. For y, I'm going to plug in negative 1. For my slope, I'm going to keep it the same, negative 2/3. For my x, I'm going to plug in a negative 6. And I'm going to solve for b. I'm going to solve for a new y-intercept. So from here, it's just an algebra problem. On the left, there's nothing for me to do, so I just bring down my negative 1. On the right, over here, I've got a fraction, and I'm multiplying it times the number. So what we can do is we can put this number over a 1. And make them both fractions, and then you just multiply straight across on the top, multiply straight across on the bottom. So negative 2 times negative 6 is positive 12. 3 times 1 is 3, and I bring down my plus b. Now, 12 divided by 3, this is a fraction. I can actually physically do that fraction. 12 divided by 3 gives me 4. And then now to get the b all by itself, I need to move that 4 to the other side by subtracting it. So my new intercept, my new y-intercept is negative 5. So now my final step, I've already solved for b, that was step 4. Now step 5 is substitute my slope and my b value back into the equation to write the equation of a line, because that's what it's asking me to do. Y equals negative 2/3 x, that's my slope, plus my y-intercept is negative 5. So there's the equation of a line that is parallel to this one and goes through the point negative 6, negative 1. So I'd like you to stop the video here and try number 2 on your own, and then you can check your work with mine. For number 2, I have the equation x minus 3y equals 9. Now, this one is not given to me in the right form, so I have to rewrite this equation into slope-intercept form. So that's what I'm going to do first. So I'm going to move the x over to the other side because I'm trying to get the y by itself. I have negative 3y equals, I put the x value first, so negative x plus 9. Okay, and now to get the y by itself, I divide everything by negative 3. So my equation is y equals, now these negative signs will cancel, both become positive. There's no number in front of the x, so I can put a 1 there. So the slope is 1/3, and then 9 divided by negative 3 is negative 3. Oops, I forgot my x. Okay, so the slope that I'm given in this equation is 1/3. I want to write an equation of a line that is parallel, so that means I have to use the same slope, 1/3. And then I'm going to take my x and y values and plug them into the equation. So now I'm on step 3. Take the equation y equals mx plus b and substitute in the values that I have. So I'm going to substitute in negative 1 for y, 1/3 for m, 3 for x, and then plus b because I'm solving for b. So I bring my negative 1 down. I'm going to put the 3 over a 1 so that it's a fraction. So 1 times 3 is 3. 3 times 1 is 3 plus b. This fraction, I'm going to reduce it. 3 divided by 3 is 1. And then to get the b all by itself, I subtract the 1 from both sides. So my b value is negative 2. So now my final step, step 5, is to substitute both my slope and my new b value into the equation to write a final equation. So it's y equals 1/3 x, my slope, x, minus 2. That's the equation of a line that is parallel to this one and goes through the point 3, negative 1. Number 3. Now, these are the same type, except this time I'm going to do perpendicular. So that means I'm going to have to take the slope, I'm going to have to take the opposite sign, reciprocal slope. So in this equation, y equals negative 2x minus 7. The slope is negative 2. Now, if you want to make that into a fraction, you can put it over a 1 as well. If it's going to be perpendicular, my new slope that I'm going to have to use is not going to be the same. I have to switch. So this was a negative, so my slope becomes positive. 2 over 1, if they trade places, becomes 1 over 2. So the slope I'm going to use is 1 over 2. I've got my x value and my y value for my points. And now I'm going to take that information and plug it into the equation y equals mx plus b. So this is step 3 because I've done this with step 2, identify everything. Step 3 is now plug it in. So 3 equals, my slope is 1/2 times x is 4 plus b. And it looks exactly the same like the problems we just did. The only thing that really changed was we had to worry about changing the slope. So I'll put the 4 on, I'll put a 1 underneath it, multiply straight across on the top, straight across on the bottom. So 1 times 4 is 4, 2 times 1 is 2, plus b. I can actually do 4 divided by 2, that gives me 2. And then to get b all by itself, I subtract 2 from both sides. So I get 1 equals b. So now my last step, step 5, is I take my slope, my new slope that I used, my new b value, and I plug it back into the equation. Y equals 1/2 x, and it's a positive 1, so it's plus 1. Okay, so I'd like you to pause the video here and give number 4 a try. Cough, cough, hint, hint, you might have to rewrite the equation. So pause the video, give it a try, and then check your work with mine. Okay, for number 4, you're writing the equation perpendicular to this equation here that passes through the point negative 5, 1. So the first step is just to rewrite the equation in slope-intercept form. So that's what I'm going to do first. I want to get the y by itself, so I subtract 5x from both sides. I get 3y equals negative 5x minus 21. And then I divide everything by 3 to get that y by itself. So my equation is y equals, now I can't reduce this and it becomes a decimal, so just leave it as -5/3 x. And then -21 divided by 3 is -7. Okay, so that was step 1. Step 2 is identify the slope and substitute either a parallel or perpendicular slope into the equation. So the slope I have is -5/3. I want to write the equation of a line that is perpendicular. That means I'm going to have to take the opposite reciprocal slope of this one here. So when I write my equation, I'm going to change the sign. So this was a negative, so mine becomes positive. And then they're going to trade places, so it becomes 3/5. My x value is going to be -5, and my y value is going to be 1. Now step 3 is substitute your m, your x, your y into the equation y equals mx plus b. So for y, I'm going to plug in 1. For m, I'm going to plug in 3/5. For x, I'm going to plug in -5, and I'm going to solve for b. So this is step 4 now, solve for b. Okay, I bring down my 1, and hopefully you're noticing that it's like a lot of the same things over and over and over again. I'm going to multiply straight across on the top. So 3 times -5 is -15. 5 times 1 is 5. And then plus b. Now I've got a division. It's just a fraction that I can actually do. -15 divided by 5 is -3. Add my b. And then to get b by itself, I will move the 3 over to the other side by addition. So 4 is my b value. So now my final step is to write the equation, and I want to plug in my new slope and my new b value. So my final equation is y equals 3/5 x plus 4. Okay, so all of these problems are asking you to write an equation, which is why my final answer is an equation for every single one. Okay, on the back, we're doing the same thing, except this time I'm giving you some graphs. So it says, consider the graph of point Q on line N. Write the equation of a line parallel to line N that goes through point Q. So first thing I'm going to do is I just have to identify a couple different things. I'm going to have to identify this point Q right here. I'm going to write the coordinates of the point. So I go over 1, 2, 3, 4, -4, and then I go up 1. So this is going to be my x and my y value when I go to plug it in. Now, I have to figure out what the slope is here because I have to write the equation of a line that is parallel. So it has to have the same slope. So remember, if you're doing slope, you're going from the furthest point on the left to the furthest point on the right. Okay, you're reading a book. Obviously, if you're going from the left to the right, this is a negative slope. So my slope better be negative. So I'm going down. If you count, you go down 1, 2, 3, 4, 5. I go down 6, so that is a -6 because I'm going down. And then I go over 1, 2. -6/2. And then to the right too. And I actually can reduce that, right? -6 divided by 2 gives me -3. So my slope is -3. So if I'm going to write the equation of a line that is parallel, I need to use the same slope of -3, and I'm going to plug in my x and my y values into the equation. And now it looks like what we did on the front side where we plug it in to y equals mx plus b, but I just had to do a little bit of extra work by identifying it in the graph. So for my y value, I plug in a 1. For my m value, I plug in -3. For my x value, I plug in -4, and then plus b. I'm solving for b. This is the step 4. Now, just like before, -3 times -4 is a +12. And then to get the b all by itself, I subtract 12 from both sides. I get -11 is my b value. So now the final step is to plug in my slope and my b value to get an equation of a line. So my equation is y equals, my slope is -3x minus 11 is my intercept. Ta-da! And that will go through this point Q and have a parallel slope. So it should look like that if I were to graph it. All right, Pause the video here, try number 6. It's exactly the same type. Okay, so for number 6, again, I'm going to write the coordinates of the point. So point Q is at -1, +4. Okay. And then I'm going to find the slope of this line. Now this is a positive slope. I'm going up a hill. So if I count, my slope is, I go up 1, 2, and I go to the right 1, 2. So my slope is 2/2, which I can reduce to a +1, right? Slope is 1. But I want to write the equation of a line that is perpendicular. So I don't want to use this slope. I want to use the opposite reciprocal slope. So the opposite reciprocal slope, put my new m, is essentially I put this over a 1 and then I flip it and I change the sign. So it becomes just a -1 is my new m value. I already have my x and my y. So now it's just time to plug it in to solve for b. Solve for b. So I've got y equals mx plus b. For y, I'm going to plug in my 4. For m, I'm going to plug in my new slope of -1. For x, I'm going to plug in also -1, and then plus b. And now it becomes an algebra problem. So 4 equals -1 times -1 is a +1 plus b. And then I move the 1 over, and I get 3 equals b. So my final step is to write it as an equation using my new slope and my b value. So my new equation is y equals negative, you can put a -1 or you can just put -x and then plus 3. On a test, I don't know, like on the final exam or something, I would assume they're not going to put a 1 there. They're just going to put a negative sign, and it's kind of assumed that you know that it's a negative. Okay. Now actually is really where you should pause because 7 and 8 are parallel perpendicular, so now you should be able to do both of these. Give it a try. Okay, number 7. Consider the graph of point Q, or excuse me, the graph of point Q and line N. Write the equation of a line parallel to line N that goes through point Q. Parallel. Okay, so point Q is at 1, so here's my, so that 1, 2, 3, 4, it's at 5, 1. Is this point Q? Now, this line right here, line N, is a vertical line. So to write the equation of a vertical line, all we do is, oh, I think I actually, okay. All we do is we're going to say, okay, if this is, I think I actually did this wrong now that I'm looking at this. This N should be over here, but okay, I'm gonna say this line is N, my bad. I kind of pushed it off to the side. Okay, if this line crosses the x-axis, it crosses it at a +1 right here. So to write the equation of this line, I just write x equals, and then it's a +1. So I'm sorry about that. I kind of flip-flopped these. I should not have done that. That was my fault, but I'm saying this is my x and this is my y. My fault about that one. That was a little off. Apologize. Okay, so I've got the equation x equals 1. Now I want it to go through the point Q. I want it to be parallel, which means I want it to be another vertical line. So I want my line to be, I have a different color. I want my line to be right here. Right here. So if I write the equation of that line, the equation is just x equals 5. And that's it. It's a vertical line. So the parallel one, this is actually my real final answer there, right? Because this was the blue one. This is my final answer. This is the equation of a line that is parallel to line N that goes through point Q. Same idea over here with this next one. So here is my X and Y. So that's what I'm going to highlight them. Okay. Point Q is over here. Point Q is at -1, -2. Okay. But I want to write the equation of a line that is perpendicular to line N. So here's line N right here. Line N is a horizontal line. And so to write the equation of line N, right, what I have to do is I'm going to say, where does it cross the y-axis? So it crosses the y-axis at a +3. So the equation for this line, that's the N line, is y equals 3. Now, I want to do one that is perpendicular. So that means instead of a horizontal line, I need to have a vertical line. And I want a vertical line that goes through this point Q. So this point Q and this vertical line, since it's a vertical line, a perpendicular line would be the equation x equals -1. And those are perpendicular. Okay, last one, number 9. It says segment AB in the coordinate plane has endpoints 1, 5, and 9, 17. Which of the following is true? So they're all talking about a line that is perpendicular to the one given to me. So here's what I need to do. First things first, I need to figure out what is the slope of this line right here. And here's how we're going to do it. The points are written as x coordinates and y coordinates, right? So point A is 1, 5. And point B is 9, 17. Now, to find the slope, the m value, we do the change of y over the change of x, or in other words, how much your rise is and then how much your run is. Now, instead of graphing it, I can do it just by looking at this problem. To find the change, I say, okay, if I'm going from A to B, how do I get from 5 to 17? Well, I add 12. So my change of y is 12. To get from 1 to 9, I have to add 8. So my change of x is 8. So my slope for this problem is 12 over 8. I can reduce that though, right? They both can be divided by 4. So 12 divided by 4 gives me 3, and 8 divided by 4 gives me 2. So the slope of my line is 3 over 2. Now, if I want a perpendicular line, that means the slope has to be the opposite reciprocal. So I'm going to switch them, and then I'm going to change the sign. So this is a +3 over 2. I'm going to make it a -2 over 3. So the slope for the perpendicular line has to be -2 over 3. So already by looking at this problem, I know A is wrong and B is wrong because these are the wrong slopes. Now, all I have to do is figure out which one of these points is going to be on the line that's given to me. Now, in order to figure that out, what that means is if this point is on this line, then this point should have the same slope as these points over here, okay? If it doesn't have the same slope, then that means it's not on the same line. So here's what we're going to do. I'm going to take, here's my first one here, 11, 5, okay? I'm going to take one of the points of the graph, and it doesn't matter which point I choose. I'm going to choose point A because they're smaller numbers and it's easier, okay? If I go from point A to point M, the slope should still be exactly the same. It shouldn't change. So I'm going to put the points 11, 5 down, and I'm going to see what the slope would be. So my slope is change of y over change of x. Now, my y value from 5 to 5, there is no change there. That's a 0. To get from 1 to 11, I have to add 10. So my slope is 0 divided by 10, or in other words, it is 0. Now that slope is not the same as this slope over here, which means this is not on this line. So that one's wrong. Automatically, that means D has to be my answer, but let's check just to be sure. So here's this one here. Again, I'm going to put my coordinates x and y. I'm going to still pick the same one, point A, which is 1, 5. And then I'm going to put these new points underneath, 5, 11. Okay, so I'm going to figure out what the slope is, the change of y over change of x. So to get from 5 to 11, I have to add 6. And to get from 1 to 5, I have to add 4. So my slope is 6 over 4. And I can reduce that by dividing both of those by 2. And I get 3 over 2. And that slope is the same as my first slope, which means this point is definitely on the line. So answer D is the correct answer. Okay, so now you should feel comfortable writing the equations of lines that are parallel and perpendicular that go through a particular point. You should be able to do it from a graph, and you should also be able to do it from straight up equations. Once you're finished with these notes, there are going to be some practice problems for you to complete on Canvas. So take a look on Canvas now and go into the modules and go into the section that says 2.3, and you will see some practice problems for you to complete, and we will talk about these on Wednesday. So hopefully you can get the notes done by Monday, maybe a little bit on Tuesday if you didn't finish them, and then do some of the practice problems on Tuesday, and we'll check everything on Wednesday. So hopefully this video helped you out, and I will see you guys soon. Have a grand day, my dears.